So in this video, we're going to walk through a few examples of finding the real roots of a polynomial. So let's look at this first example here. This p of x function is 4 terms. And generally what you're going to try to do is factor. If there's any factoring that can be done, you want to do that. And so here we're going to use grouping, and that's where you group the first 2 terms and then the third and fourth terms together. And I can factor out an x squared from the first 2 terms. And I'll have an x plus 3 remaining. And then I can factor out a negative 4, and I'll have an x plus 3 remaining. And then with grouping, when you have this repeated factor, so see there's 2 terms here now, right? We have 1, 2, and we have this x plus 3 as a repeated factor in each. And that means I can now factor out the x plus 3 from each of those 2 terms. So when I take the x plus 3 out of the first term, or divide that out, I'm going to have an x squared. And when I take the x plus 3 out of the second term, I'm going to have minus 4. And then this will actually factor a little further. We have a difference of 2 squares. So we can factor that to x plus 2, x minus 2. So this is the factored form of p of x, okay? And so this tells me that I'm going to have real roots at -3, -2, and 2. Remember that each of these factors give us a root, okay? And remember it's always x minus the root. So here I'm actually subtracting a -3, and that's why I have x plus 3. So that's why I have -3 as the root, okay? So this particular first p of x function had 3 real roots, -3, -2, and +2. So let's look at this next one here. This p of x function is a 4th degree poly, which tells me we can have up to 4 zeros, okay? And so we're going to try factoring. And this is a trinomial, so I'm going to use x squared and x squared as my first term. And then I can use -4 and then +1 as my other parts of each binomial. And then that is my first step of factoring. Then this binomial here factors more, so I can factor that more to the x plus 2, x minus 2. This second binomial here does not factor more. It would need to have a subtraction sign in order to factor more. So I'm just going to bring that one down. Okay, so what I'm going to have here is I'm going to have a situation where for my real roots, I'm going to have a -2 and a +2 from those first 2 factors. Now this third factor here, if I solve this, set it equal to 0 and solve, then I get plus or minus -1, square root of -1, I should say, and that's plus or minus I. So those are going to be what we call complex roots. And we will do more with those as we get a little further down the road. And let me just write them separately here. So that's I and -I, okay? So as far as graphing goes, we can use these real roots on our graph to help generate the graph. Our complex roots, those are not actual x-intercepts. They do give us information about the polynomial, but we can't actually use those to generate our graph. But we could use these real roots here if we were trying to graph this. All right, and so let's go down to this third one here. This is a 3rd degree polynomial, so that tells me we have up to 3 roots. I'm going to use factoring. Notice here I have a greatest common factor of x. So I can factor that out of each term. And then I have a trinomial that will factor more to x plus 4, x minus 2. So for this one, I'm going to have 3 real roots. I'm going to have a 0 from this first factor. I'm going to have a -4 from that second factor, and then a +2 from that third factor. So these are my 3 real roots. Okay, so here's just a few examples of finding the roots. Like I said, we're going to try to use factoring when we can. As we progress, we will talk about what to do when maybe something doesn't factor, but that will come a little further down the road, and I'll see you in the next video.